One interesting method of bypassing the base DLL address randomization is by implementing a partial EIP overwrite. Let's explore this vector slowly. We'll begin by shortening our buffer to 56 bytes rather than 58, effectively overwriting the lower 2 bytes of our EIP at crash time. Let's try this out. So I'll make a small change here, and I'll change the buffer length to 56, and I'll save this file. Let's try crashing Internet Explorer again and see what effects this change has. I'll attach Ollie once again. Allow the browser to continue execution and refresh the page. Look at that. The resulting crash is very interesting. We can see that our plan to overwrite the lower 2 bytes which overwrite EIP has succeeded. We can also see that at crash time, our execution flow is located in user32.dll. We can see this by identifying the address that EIP is pointing to and realizing that this address is located in user32.dll. Another interesting point to notice is the location of our buffer. If we look at the EBX register, it's pointing to an address which points to our buffer. We've basically been redirected to the beginning of our ANI header. So EBX contains an address which points to our user-controlled buffer. This is the beginning, the header of the ANI file, RIFF. So essentially, if we can control the execution flow to redirect us to the address that EBX is pointing to, we will reach to this area, which is already controllable by us, and hopefully we should manage to shove some shellcode in here, which will give us a reverse shell. So the bottom line is that we need a jump to pointer EBX instruction in order to reach our user-controlled buffer.